4, this side does not work. All right, let's go ahead and take a look at the next one. So Diego's goal is to walk more than 70,000 steps this week. The mean number of steps that Diego walked during the first 4 days of this week is 8,019. Write an inequality that expresses the mean number of steps that Diego needs to walk during the last 3 days of this week to walk more than 70,000 steps. Remember to define any variables that you use. So for this one, his goal is to walk 70,000 steps or more. Okay? Or not or more. More than 70,000 steps. So that's going to be greater than, because he could walk 80,000, that would be great. He wants to walk more than 70,000. Now it says his average that he walked is 8,019. That means per average, if he were to add up all the days and divide by 4, he would get 8,019. But then I can also see if he walked an average of that, then if we multiply 8,019 times 4, that will give us how many he walked total. So he walked 32,076 so far, plus we need to figure out what would the mean number of steps or the average number of steps need to be if he were to walk for another 3 days. So we can set up our equation this way. 32,076 steps plus 3 times the number of steps he walks each day has to be greater than 70,000. So we can start by subtracting 32,076 from both sides. So 70,000 minus 32,076. And we'll get 3s is greater than 37,924. Divide both sides by 3. And so now we know the average number of steps he would need to take is 12,641.3. So really 12,642. And it says if the mean number of steps he walks is 12,642, will Diego reach his goal of walking more than 70,000 steps? So we know that steps has to be greater than this number, and 12,642 is greater than that, so yes. All right, the second part of your homework is a review, and so we are going to be looking at our systems of equations. Now here with this systems of equations, we have x over on here, but x on this side in the second equation. So I need to manipulate the first equation a little bit to make it look more like the second one. So if we have 3y plus 7 equals 5x, I'm going to start by subtracting 5x on both sides. This will give me, on this side, negative 5x plus 3y plus 7 equals 0. Now I need for the 7 to be on the other side, so I'm going to subtract 7 from both sides, and I'll get negative 5x plus 3y equals negative 7. Well, now I can write that up here, and I can combine like terms with the second equation, which is really nice because we have a situation in which we have opposite coefficients here that will cancel out. So 7x minus 5x is 2x, 3x and negative 3x is 0 equals 1 and negative 7 is negative 6. Divide both sides by 2, we get x equals negative 3. Then you need to go back and plug in x, wherever x is, negative 3, to solve for y. So I'll let you do that part. Put a star next to that. That's an answer I'm looking forward to see on your paper that you solved yourself. All right. For number 6, we are lucky in that these are already lined up. So unlike the first equation, we have an x over an x, a y over y. They're on the same side of the equal sign. So that'll make that combination a little bit easier. I don't need to do this manipulation that I did up here. However, I have opposite signs of coefficients, but not the same coefficient. And so I'm going to need to do something with that. So I'm going to go ahead and multiply the equations to get the x values to equal 15. So to get to 15 here, I need to multiply 5x times 3. And to get to 15 down here, I need to multiply by 5. And that's because that's my least common multiple there. So let's rewrite this. I'm going to get 15x plus 14 times 3, should be 42, I believe, yes, plus 42y equals negative 15. And then negative 15x plus 50y equals 5 times 72 is 15 minus 15 is 0. That cancels out. That's what we were hoping to get. We get 92y equals 360 and negative 15. It's going to give us 345. Divide both sides by 92. And we get 375. So y equals 3.75. All right. So then to get x, you go back, plug that in. I'm going to go ahead and tell you x will also be a decimal. So solve that, put a star next to that. That's the answer I'm looking for that you did on your own. All right, letter B. For letter B, we have a similar situation. Our positive and negative opposite signs are in the middle here. And it looks like I can't divide anything to make them nice and even because 289 divided by 5 is not going to give me a nice even number. So instead what I'm going to do is think about what is the least common multiple for these that I can multiply both of them by to create. So the smallest number that both 9 and 5 can create is actually going to be 45. And so I want to get my middle terms to be 45, so I'm going to multiply by 9 and multiply by 5 on the bottom. So this will be 180x minus 45y equals 289 times 9, 2,601. And then at the bottom, 5 times 22 gives us 110x plus 45y, which is what we're looking for, and then 5 times 257 equals 1285. Our middle terms are going to cancel out because 45 minus 45 is 0, and then this will be 290x equals 261 plus 2,601 rather, so we end up with 3886. Divide both sides by 290, and we get that x equals 13.4. So again, you have x, go back, plug that in, solve for y, and you'll get a nice answer there. All right, number 7, Lynn and Noah are solving this system of equations. Noah multiplies the first equation by 12 and the second equation by 8, which gives this system here. Lynn says, I know you can eliminate x by doing that and then subtracting the second equation, but I can use smaller numbers. Let's try multiplying the first equation by 6 and the second equation by 4. Let's see if she's right. So if we have 8x plus 15y equals 58, and then 12x minus 9y equals 150, if I multiply the top equation by 6 and the second equation by 4, I will end up with 48x plus 6 times 15, which gives us 90y equals 58 times 6 is 348. And then the second equation, I get 48x. So already I see I have something in common here, which is nice. Minus 36y equals 600. Okay. So yes, because this creates a coefficient of 48 for my x terms. It says, what are the smallest whole number factors you can multiply by? So is there something smaller than 4 and 6 that we can multiply? Well, I know that 12 and 8 have a least common multiple of 24. So yes, we could multiply the top equation by 3 and the bottom equation by 2, because this would give us 24 for our coefficients of x. And then we could go ahead and subtract the whole thing from the top. All right. Alternatively, just as a side note, you could go ahead and then subtract these, or you could multiply with one of them by a negative to begin with, and that would also allow you to just cancel them out by combining like terms. So if you were saying, oh, they should have multiplied by a negative, that would also be a valid response to go ahead and help to cancel out those terms in one move instead of two. All right, our last question is a opportunity to practice another inequality. And so here, as we practice today in our do now, we have a denominator of 2. So I'm going to show you this a little bit more closely because I noticed some of you were still a little confused with that. So this is distributive property. I'm going to distribute 2 times x plus 2 all over 2 is greater than or equal to 2 times negative 7 is negative 14 minus 2 times x over 2. So the 2 on the bottom in the denominator doesn't just automatically disappear because we multiplied by 2. What's happening is we now have a 2 in the numerator here over a 2 in the denominator. And so this 2 divided by 2 is 1. And that's why it's able to cancel out. Same thing with this one over here. The 2 divided by 2 is 1. So that cancels out. So we're left with x plus 2 is greater than or equal to negative 14 minus x. And so now I can combine like terms. So I'm going to add x to both sides, and I'll end up with 2x. And then I'm going to subtract 2 from both sides, and I'll have greater than or equal to negative 16. Now, an interesting thing here is that we are dividing both sides by 2. On this side, there is a negative, but we are not dividing by a negative. So that sign flip only happens when we're dividing by a negative. So this is going to remain x is greater than or equal to negative 8. And if you want, we can prove that by looking at a number line here. So if we look at the number line here and we put our negative 8 as the answer, to this side of it is 0, to this side is a greater negative number like negative 12, for example. All right. Now, if I were to plug in 0 here, I would get 0 plus 2 is 2. 2 divided by 2 is 1. Is greater than or equal to negative 7 minus 0? Yes. 1 is greater than or equal to negative 7. So this tells me that my graph is going to be going up in this direction and therefore is a greater than situation because my answer should be more than or greater than negative 8. All right. Let's go ahead and go back to this classwork. Remember, I said you can skip number 4, but I'm going to take you to number 3 just to go ahead and make sure you're very clear on this. Now, just a quick note, this is like this, okay? That is not 1.6, it's 6x. So 6x is less than or equal to 3x. Well, let's see here. If I were to subtract 3x from both sides, then I would get 3x is less than or equal to 0, and therefore x is less than or equal to 0. So let's try that. If I were to put negative 1 here, that would be negative 6 is less than or equal to negative 3. That is true, so that works out. So the less than sign works out very nicely there. So this is less than or equal to, so this would be F as presented here. This color is terrible. Let's choose a brighter, shinier color. All right. 1/4 x is greater than or equal to negative 1/2. If we multiply both sides by 4, I can then do 4 over 4 is 1. So we're left with x is greater than. We end up with 4 over 2, which is negative 2. And so we're looking for where x is greater than negative 2. So open circle, negative 2, that's going to be E. For number 3, I can either subtract 5x or 7x. Let's go ahead and subtract 5x from both sides. And we'll get 4 is greater than or equal to 2x. Divide both sides by 2. We get 2 is greater than or equal to x, which can also be written as x is less than or equal to 2. And it's a less than or equal to sign, so it should be filled in, so that is B. All right, let's look at the next one. So for number 4, the key here is on the right side we need to distribute first. So we have 8x minus 2 is less than negative 4x. Then a negative times a negative is positive 4. All right, I'm going to go ahead and add 4x to both sides because that'll give me a nice big positive number on the left side there. We have 12x minus 2 is less than 4. And then I'm going to add 2 to both sides, so I'll get 12x is less than 6. Divide by 12. We'll get x is less than 1/2. And so I'm looking for a place where there's a 1/2 and it's a less than an open circle. That would be here, D. Okay? All right, there's 2 more. And so those last 2, I want you to figure out, since I gave you the first 4, you can eliminate. You've got 2 left, which one goes with which, and you should be able to tell that pretty easily just by the signs. But go ahead and practice working them out. The hint is multiply this one by 3 all the way through. And again, make sure to distribute, okay, because that'll help you to see this, right? What happens then with these 3 over 3, this 3 over 3. Okay, same thing down below here. I would just go ahead and multiply this whole thing by 5. Remember, you have to multiply each term by that. So 5 times 12 is 60. 60 divided by 5 is 12 because 5 over 5 is 1. So we have 12 minus x is less than or equal to 5x. See if you can continue from that point forward. Make sure to show your work. All right, your code word for today is pothos. It's a type of plant, pothos. I'll see how you spell it, and if you were listening carefully, you can tell me it's a type of plant. Happy homeworking, have a wonderful weekend, and I will see you on Monday.